Welcome everyone to our second in a series of webinars on SEND, and we're excited and thankful to have you on today. Please send in your questions to our moderators. We are going to be posting the questions and answers early next week, along with the recording of this webinar. Some background information. PointCross was founded in 1999 and has been serving the life sciences industry since 2009. We participate as members of CDISC, FUSE, and we have a conversation with the FDA regularly, including as a contracting partner with them. The XBiome technology platform, which we're going to be using today, serves as a base for non-clinical, clinical data and metadata repositories, regulatory submission workflows, and an analysis, data visualization, and validation platform. Large sponsors and small biotechs alike have entrusted PointCross with their non-clinical studies and clinical information, with almost 10,000 studies processed. Some of our services for the non-clinical side of industry include SEND generation, 100% QC of SEND datasets, interim study monitoring, and study data repositories. If you would like more information on these services, please visit our website, where you can also find our automatic quote generator. This is the second in a series of non-clinical webinars dedicated to improving the quality of SEND across industry. Our next webinar will focus on a more in-depth on cross-study analysis and study data repository. XBiome, the platform that we're going to be using today, is a 21 CFR Part 11 compliant and validated system. It is backed by AWS and is entirely web-based for any end user. For security purposes, the system includes user-based role access, which can be edited by an internal IT team and does not rely on the PointCross team. The XBiome platform is highly customizable, including templates and options to collaborate with teammates on visualizations. And all of our SEND customers do receive XBiome access for each deliverable for visualization and QC checks at no additional charge. All visualizations that we're going to be showing today can be exported. Tables can be exported into files such as Excel or CSV, images into JPEG or PDF, and any export can be added directly into a PowerPoint for your organization's internal presentation needs. Today, we're going to be covering the topics using XBiome. First, we're going to start with visualizing SEND datasets and how you can use the different tables and figures to QC your SEND datasets. We will speak to how you can use XBiome to individually walk through subject level data to tell the story of your study's outcomes. And with these, we're also going to be doing some predefined templates, going through different cohorts, and specialized analytical review, along with cross-domain analysis. And please give me a moment as I pull up the XBiome for demonstration. Okay, you should now be able to see the application. As you begin, XBiome is an easy-to-use platform. Everything that you will need to use will be templated or set up for you. Advanced users can build their own scripts, visualizations, and graphics. As mentioned, every SEND customer does receive XBiome access for their deliverable. If you have SEND datasets already prepared, you can also upload SEND datasets for ingestion into your organization's unique business base. Not all data has to be in SEND for ingestion. PointCross routinely digitizes PDF study reports for analysis in both creating SEND and for documentation purposes on XBiome. Approximately 60% of SEND datasets PointCross creates come from only PDF study reports, with limited to no electronic data available from LIMS or data capture systems. This first study that we're going to cover is going to visualize an example dataset. It's a 4-week toxicity study in rats with a 4-week recovery period. There are also toxicokinetic groups for the dose groups, but not for the control group. As an introduction, I'm going to show you the body weight graph first. This graph is going to show the summary of the group over the course of time. So as the screen has opened as is, on the left side, we have a visualization of the males over time. And on the right side, we have the females. Each of the colors in the graphs is representing a different group, which is going to be labeled on the far right under group description. And they are separated by TK. So the first 4 groups are the non-TK groups, and the last 3 are TK groups. The figures are labeled on the x-axis along the bottom as the nominal day, and the y-axis as the body weight in grams. One thing to note as we're going to be looking at this, the top group under group description is a bright lime green and it has a star. And this denotes that we've identified this as the control group. This is going to be the reference group. We can explore what happens to the groups as we're using this control group as a baseline. There's a set of options on the left-hand side of the screen, and we can toggle between a few different types of settings. I'm going to switch over to individual records, and this is how we can evaluate the Send dataset by visual inspection. So when I switch to the individual, you can see that there's a lot more lines. This is going to represent all of the subjects as opposed to all of the groups. So looking at this, I do see that there is one data point that I would be questioning. When I'm looking at this, I'm seeing that in the bottom right corner of the females, there's one data point that's not exactly in line with the rest of the group. So I'm going to take my tool and I'm going to inspect this individually. As I'm going through this, I would like to have my study report open at the same time, which can be viewed and minimized in the corner. But at this time, as this is an example study, there is no study report to go along with it. So if I take a look at that last data point, it was on day 57. I see that it did gain weight from the past 2 weeks. From day 43, it was 227 grams. Day 50 was 229 grams. And day 57 was 253. So there was an increase, but it's not exactly what I would have expected based on the other subjects. If I had my study report open and I double check these values, I'm going to assume that this is correct, but I've now added an additional QC check to my Send dataset, and I ensure that the value matches what was collected. Similarly, I can use some auto-generated tables, and I can compare them to the report, and we will get those in a moment. Back to the options on the left-hand side, I'm going to evaluate the change from the reference group. And so we're referring to this bright green line in the very center. This will always be marked as 0. There is 0 change from the reference group, the control group, to itself. It is always going to be referring to itself as the baseline. So the green line is going to represent the quote normal change over the course of time, whereas the other lines are representing the different groups or different subjects. The reds are definitely showing a decrease in the rate of change compared to the control group. So even though they were increasing compared to the last visual where we only evaluated the true weight, the rate of change is nowhere near what it was expected to be in the rest of the control group or even the other dose groups. We can see just along day 29 that there is a serious drop in the change of body weights. It's about 100 grams less than the rest of the reference group. Additionally, we could also go into the percent change and see what their rate of change from the reference group was. So along the top, I'm going to switch into a table view. And in this table view, I'm switching back to the summary. Along the left are the labels of how I've chosen to separate the groups. Currently, this is the sponsor defined groups that it's separated by. And at the top, I can choose different separations. So if I wanted to, right now, this is separated by the dose and the TK status. but I could also separate it into the trial sets. And this gives me information in the non-recovery, non-TK group, the recovery group, and the TK group. I can also split it out just by dose, and this would combine all of them regardless of their recovery or TK status. But I will go back to the sponsor group. Along the top is going to be the days of the study. We're using the nominal day in this case, but these can also be changed. Below that is going to be the epic. So we have the pre-study, treatment, and the recovery. This is being pulled from the trial design information. So this is another way to check that if my trial elements or subject elements were off, these epics would be populating incorrectly and we'd be able to see that. Within the table itself, we have the mean, standard deviation, and count. I can compare this with the finalized study report, which has tables generated from the LIMS system, data capture system, or if they were made by hand with a statistical analysis. Should these summary counts match the report, we can be fairly confident that our send dataset is correct. There are also additional operations that we could perform if we had information such as min and max. If we needed a variance between that, we could click any of those and it would automatically generate and compare that to the report. If any of these summary or count values are off, there is going to be a mismatch with the report. The send dataset should be evaluated, and this is another check that you have where everything is summarized. Next, I'm going to be switching over to the microscopic findings domain. For the MI domain, findings are going to be organized by the tissue, the finding itself, the disposition term and day over to the left, and on the right-hand side, they're separated by severity and sex. This view is labeled as the consolidated view and can rebuild the same tables that are presented in the report so that you can QC your send data set against your report. I'm going to unclick the disposition term and the days, and this way all of our findings are together regardless of their disposition term or day. All group 4 subjects are with group 4 subjects. XBiome has a color gradient that's built in to make QC easier and pick out where findings occur at a higher incidence. Once we evaluate all these subjects together by removing the disposition term and day, we can see that there's a fairly high incidence of hypocellularity in the femoral bone marrow for the group 4 males, with 13 out of 18 subjects evaluated having findings here. So this is going to summarize all of your send dataset into the exact report, and it easily rebuilds the report tables. I'm going to switch over into the magnifier view. And with this magnifier view, I can see that the majority of records in my send dataset are unremarkable and they are labeled as normal in here. So these are all of the green records. We can either use this to QC, or we can keep it as is and evaluate by clicking on the different sections, or we can exclude the normal values and only see the records with findings. So I'm going to exclude the normal values now. Now that I've excluded them, I can individually click on the findings and evaluate how many we actually have in the data set. And I can compare this to the report, look for some extreme outliers, look at the names of the findings and specimens, and do an additional QC check here. I'm just going to do a quick click on the liver. And I see that of the remarkable records in the data set, 48% of my findings are in the microscopic findings. I would be able to do an additional click on there, and then I can zoom in a little bit further and see where they were separated out into, such as hypertrophy. And I see that's 26% of the liver findings or 13% of the microscopic findings overall. As we've discussed in our previous webinar, send datasets are generated based on an already completed study. The report is already completed at the time that the send dataset is created. Some of the visualizations that I've shown are only usable once the study report is completed, specifically this microscopic data. It's great for QCing send data sets where it's pretty common to have MI data done at a separate test site and then later incorporated into the full data set. But some of the visualizations can be used while the study is ongoing. We use the body weights and clinical signs, for example, to evaluate if there are any signs of toxicity in the study as it's ongoing. I'm going to switch into the microscopic findings versus the lab test results. And this is going to be an example of our cross-domain analysis. So on the left-hand side, we're going to select a specimen and finding, and then we're going to look for correlations with the parameters. So on the left-hand side, I'm going to click liver and cytoplasmic alteration. And then on the right-hand side, I'm going to select, just looking for any of them. I'm going to select potassium because I know that there's no correlation here. When I've selected this, I see that there are at the very bottom right, we're plotting the potassium against the severity of the findings. So we see that where there are cytoplasmic alteration findings, they do have various levels of potassium, anywhere down from 4.5 up to 5.5. And that's seen where we also have findings. We have the absence of findings. There is no cytoplasmic alteration with potassium levels at any point. I switch into something that I know is going to have a relation, and this is going to be the bile acid. We see that as the bile acid findings get higher, they're going above 200, we see that they are more likely to have the cytoplasmic alteration, especially with the values over 300. We see that it's only the dose groups that even have any cytoplasmic alteration here with any sort of severity. The lower the dose, the less severe, but the higher the dose is getting, the more likely it is to have the severe finding. The third and fourth groups did have some of the higher bile acid findings, and they are in between 3 and 4 on the scale of 4 here at a severity. I'm going to unclick the cytoplasmic alteration and click into the hypertrophy, and we're going to see very similar findings that the bile acid was related to a lot of these liver findings. We have the mid-dose group, 25 milligram per kilogram, has a lot of findings at 1 and 2 on the severity scale. And then the high dose group, as they are getting higher bile acid readings, they are having more severe 3 and 4 out of 4. So I'm going to switch over into another study. This is actually the same study, but ingested on day 15 instead of at the very end of the 4 weeks plus 4-week recovery. So we're going into the same body weight now and switching over into the individual. And I can see that the purple group, which is the high dose non-TK, is trending a bit lower than the rest of the groups. The purple really stands out over here towards day 15. But it's not just a single subject, it's almost all of the subjects that are trending a bit lower. So I'm going to take my tool again, and I'm going to look at this very bottom point, again, just to see if this is a divergent value or if I can evaluate if there's anything else going on. So I see that on day 1, the subject was 264 grams. It goes up to 292, and then it drops back down to 242 grams. This has the lowest body weight out of any of the subjects, and I'm going to look to see if there are any clinical signs going on at this point. I see that there are no clinical signs going on. That's all right. So with rats, the weight loss is a bit more severe. If this were a larger subject, a rabbit or a monkey study, the body weight loss may just be a loss of appetite over a day or two, but a rat would not be expected to lose weight like this. So with no abnormal clinical signs, we might alert a study monitor at this time to evaluate the subject more closely. This may even trigger some GLP, OECD guidelines following into, I think this is actually a 20% loss here that may fall into euthanasia criteria. But again, this is a made up study. I'm also going to add in the food consumption, which I can do right on the same page, and I can evaluate the food consumption over the course of time. So I do see from day 1 to day 8, the subject was eating, actually up until then, a fairly standard 5.6 or 5.4 grams per day. But on day 8, we do see a drop off. And from day 8 to 15, it was only 4.7 grams per day. We are getting a little bit of an insight that from days 15 to 22, maybe this is actually ingested a few days after day 15, it was down to 3.4 grams per day. So this may explain the body weight loss. When we evaluate these studies in an ongoing manner, we're able to find much quicker if there is a potential error in the data set or the report because we are collecting the data immediately. So whereas I'm finding this information to possibly alert a study monitor, I'm also keeping note of this as the um, sponsor and CRO are performing their report to know that there are some aberrant values or values that may statistically be outside of line, and that may impact the rest of the report. I've now switched over into another study, and I'm going to take a look. It's a little more robust. The study that I've just switched over to is a 4-week repeat dose toxicity study in monkeys, and the test article that is given once per week intravenously. As this is a larger subject, we have a little bit more information with laboratory tests can be taken, and we can see a change over time. One thing to note is that the colors of the groups have changed. They are going to be from lowest to highest dose, but they are different colors, and the color guide is to the very right of the screen when we go into it. All of the colors can be changed per study as a feature of XBiome. So I'm going to take a look at the laboratory tests. So we see that black is going to be the control, which is a 0 dose, and over to the teal is going to be the high dose at this time. We've taken days -1 and days 28, and I would expect all the groups are approximately the same on day -1, as no treatment occurred. If the values on day 28 are much higher or much lower than other groups, there may be some sort of treatment-related effect. So we have picked out that in this study, the bilirubin has a definite increase for the high dose group on day 28. The other dose groups don't seem to have the same effect. And I've now seen this trend where it's going up. I can add in on the left-hand side a standard deviation to see if it is a variance or not. And I can see that the standard deviation is approximately the same for each group. So I don't suspect that this is a single subject. I suspect that this is the entire group. So what I'm going to do with that is I'm actually going to take out all of the parameters except for bilirubin, leave just that one. And I'm going to switch instead to individual. Now that I've switched into the individual, I can see it's pretty much the same. I'm going to confirm this with the summary tables. And if I'm intimately familiar with the report, I know that there's to be a change expected in bilirubin. But I can see that it should not be a shock if I'm the one that's manually QCing this information, that the bilirubin is much higher at 0.2 compared to approximately maybe 0.12 for the rest of the groups. And I'm going to switch into the pharmacokinetic concentrations at this point. This is how I'm going to take a look and see if everything should be in line. We're only visualizing groups 2, 3, and 4 as the 0 dose was not evaluated in this case. I'm going to do a quick visual QC and see that, as expected, the higher dose group, so this teal, is always going to have a higher volume of drug on board, and it's always going to be slightly higher, but it's following the same rate of decay. On day 22, it stays a little bit higher, a little bit longer, as it's been receiving this over the course of time. I'm then going over to immunology. So we've also included immunology data in this study. We've mentioned that the study's route of administration was by intravenous use. It can be a biologic that is being sent for CBER for approval, and specifically this one is being used to study anti-inflammatory agent. Blood samples were obtained from subjects on day -1 and day 28, same as the laboratory test, and we're going to be determining the anti-drug antibody titers, or ADA. On the left are the males, and on the right are the females again. From left to right, it's going to be color-coded from control onward. So please note that the ADA levels are lower on, or low in general on study day -1. However, on study day 28, there are higher levels for the dose groups. With this information, we might want to look at the PK parameters to see whether the subjects with the high ADA titers might also have low exposure levels. So we'll add in the next parameter, which is going to be for the AUC to last non-zero concentration. And that was just added below what we visualized. So though it's not immediately visible, I'm going to select two groups. I'm going to select just groups 3 and 4. And as we mentioned, they're going left to right from the low dose to the high dose. This is also going left to right in the order of subjects. So what I'm going to be seeing is that there is an inverse relationship between ADA and AUC. As the left side of the subjects have, at least in group 4, have the high ADA, they also have very small AUC levels. So they're so small you can barely see them on the bottom. In the top one, you can see the ADA. They're definitely present, but they're much lower than the other subjects. But in the bottom, we can see that the AUC is much higher. I'm going to select 2 individual subjects, and we can see that a little bit better. We see 2 very low values in the AUC and 2 very high values in the ADA. So I've reset the subjects, and as we mentioned, the therapeutic under evaluation is going to be an anti-inflammatory product. The expected pharmacologic class response is a decrease in the tumor necrosis factor alpha, and I'm going to add the TNF under the AUC bar. So now that we've added that, we have the 3 parameters, ADA, AUC, and TNF alpha. So we're going to look at these and see that when there is a high ADA, so looking at some of these subjects up here, and the low AUC, we do not show a decrease in the TNF alpha. All of those high subjects also have all of the high ADA also have high TNF-A. It's not just the studies in SEN 3.1 that can be visualized. We're also going to take a look at, we can take a look at reproductive and safety pharmacology studies that are in current scope or otherwise covered under SDTM, brought in with custom domains, such as the immunology data in this study. PointCross believes that SEN datasets should include all relevant information to study analysis, and custom domains are part of our SEN services. So the next one we're going to look at is a safety pharmacology study. This study is a cardiovascular and ECG study on dogs. It's in a Latin square design. And we're just going to take a look at the cardiovascular for the study. So as we said, it's a Latin square design. It's a little busy. We click over to the individual, it gets even busier. There's still some information we can pull out from this. The very bottom test, systolic blood pressure, we can see that a lot of the data points are overlapping, but this high dose, which is labeled in red, is consistently lower. So if we select just the control group and the high dose, we are going to be decluttering it a bit. So in both males and females, up until about an hour after the dose, the data points are very mixed in. But as the drug starts to take effect after the oral administration, the high dose has a much lower systolic blood pressure, and this is across the males and the females. Now that we've separated them out, we can actually see that the high dose females also may have a slightly increased heart rate. and a slightly decreased mean arterial pressure. The diastolic blood pressure is at the top. It's a little bit mixed in, but the trend lines are similar to some of the others. So since we've added in the reference group, I'm going to add in the change from the reference group. And again, only looking at the control and the high dose. And we see that's a little bit clearer. There is definitely a decrease in systolic blood pressure and mean arterial pressure, and there is an increase in the heart rate. So there is some sort of impact with this high dose. So I'm going to add in the change from baseline as well. So this is not only taking into account the change from that group, but also the change from the subject's own baseline. So we've added that in, and we're going to refer to this as the double delta graph. The first change delta was from the original baseline. Each subject acts as their own baseline at the 0 hour mark or immediately before dosing. The second is going to be the time matched dose to the vehicle or control, which we see going right across the 0 here with that green line. Once again, any of these points can be individualized, separated, saved into a table or figure, and evaluated further. And any other trends that we see, we can then compare to the data set. If we're looking at just numbers, we have to compare to the table, but seeing the trend line makes it easier to see if there is supposed to be an outlying value in here. With that, this is going to complete our second webinar. Let me just share my screen again. As mentioned before, if you have any questions, please ask them in the chat, the Q&A. They will be posted to our website early next week and emailed out to every one of the participants, along with the recording of this webinar. In our next session, there will be a third one. We are going to be going over cross-study analysis and repository information, and we might dive a little bit more into the cross-domain analysis with some more in-depth. So we will leave this open for another 5 minutes or so to ask any questions. And if you have any other questions, you can contact us at ask@pointcross.com.